everyone, welcome back to another beautiful episode of Just Ask Sage. Happy New Year, everyone. I want to welcome you to the wonderful year of 2026. Hopefully, this year you are going to see more of me. Hopefully. Alright, so we are going to start the first video of the year by continuing our marathon of calculus. So today we are going to be talking about the chain rule and the implicit differentiation. So the chain rule states that dy by dx equals dy by du times du by dx. Your chain rule is also called a function of functions, and you use the chain rule when you have, well, a function inside another function. Or what I used to remember when to use chain rule is that whenever you see power, that's one big looking function and it have power, just know you're going to use chain rule. Let's use an example to demonstrate it. Now let's take a look at this example here. As you can see, we have a function inside another function. What do I mean? This function 3x squared minus 5 is a function on its own. Then another function again is now that the function is now raised to a power. So it's like it's as if it's inside another function power 4. So whenever you have something like this, like I said, what I used to remember chain rule is that it usually have power. Once you see a power like this, just know you're going to make use of the chain rule. Now from our chain rule, the formula, we have dy by du and we have du by dx. It means we have just one parameter in the chain rule. The parameter is called u. Now, how do you name your parameter? Your parameter is simply your inner function. And the inner function in this case is what's inside the bracket, which is our 3x squared minus 5. So you start by saying, let u be equal to 3x squared minus 5. Now, if we substitute this u as 3x squared minus 5 into this our equation, that means our y is simply u raised to power of 4. You are replacing this 3x squared minus 5 with the u. That's the inner function. So now, to get your dy by du, you differentiate the one that have y and u. Then to get your du by dx, you differentiate the one that have u and what? X. Good. So let's get our dy by du. Like I said, dy by du is gotten by differentiating the one that has y and u. So if I want to differentiate this u raised to power of 4, just bring down the power and subtract 1 from the power. That will give us 4u to the power of 3. This is for dy by du. Then to get our du by dx, this is gotten by differentiating our u with respect to x. So to get du by dx, here we have 3x squared minus 5. Differentiating 3x squared, you bring down the power. If you bring down the power, you'll be having 2 times 3x raised to the power of 2 minus 1 minus, differentiate 5. 5 is a constant. Derivative of a constant will give us 0. So this will simply give us 6x only. So now from the formula, you just have to multiply your dy by du and du by dx. So therefore, our dy by dx will be equal to dy by du 4u raised to the power of 3 times du by dx 6x. If you multiply these two together, first start by multiplying your constants. 4 times 6 will give us 24. So that will be 24x u raised to the power of 3. But initially, u was not in the question. So when you are done differentiating using your chain rule, you must always replace your u back. I remember our u was what? 3x squared minus 5. So we're going to be replacing this back. So that will give us 24x. Then you can open your brackets. 3x squared minus 5. Remember, it's u raised to the power of 3. So it will be raised to the power of 3. So this is the derivative of our function here using the chain rule. Alright, let's take another example. Here we are asked to differentiate this function. This function is also going to be making use of chain rule. Now this square root can be, this function here can be rewritten as 5x cubed plus 2x raised to the power of half. Because square root simply means something raised to the power of half. Alright, so this chain rule because we have a function inside another function carrying power. So like I said in the first example, we'll first of all name our parameter u, and our u is our inner function. So first of all, you will let u be equal to 5x cubed plus 2x, our inner function inside the bracket. This means that our entire function y is simply equal to u to the power of half. So from our chain rule formula, we need dy by du and du by dx. Here, our dy by du equals u raised to the power of half. Differentiate this. First of all, bring down half. So this will be half, then u raised to the power of, subtract 1 from the power. That's half minus 1. And this will give us half u raised to the power of half minus 1 will give us minus 3 over 2. Now, if you apply your laws of indices, if you have negative power, your function, which is in this case u, will have to go down. So if you rewrite this using laws of indices, this will be 1 over 2u to the power of 3 over 2. These are dy by du. Now next we need to get our du by dx. Now du by dx means differentiating u with respect to x. Our u here is 5x cubed plus 2x. To differentiate this, first of all, differentiate 5x cubed. You bring 3 down. So this will be 3 times 5x raised to the power of 3 minus 1 plus 2x. Remember I said something like, if you want to differentiate a function that have just the parameter no power, that's here in this case 2x, that the power is 1, it will simply give us back the coefficient, which is what? 2. This means that du by dx is 15x squared plus 2. So now applying our chain rule, remember you simply have to multiply this dy by du and du by dx. So therefore, our dy by dx is equal to, multiplying these two, 1 over 2u to the power of 3 over 2 times 15x squared plus 2. So this will give us, this will turn to the numerator, 15x squared plus 2 all over 2u to the power of 3 over 2. Now, like I said, you have to replace your u. So this means that our dy by dx will be 15x squared plus 2 all over, replacing our u. Our u initially was 5x cubed plus 2x. So this will be 5x cubed plus 2x raised to the power of 3 over 2. So these are derivative to the function here. I hope with the examples we've illustrated above that we've been able to understand what the chain rule is all about and how to apply the chain rule. So moving on, we are going to be looking at the implicit differentiation. The implicit differentiation doesn't necessarily have a formula. It just, you use implicit differentiation when you have a full-blown equation, not a function, no, an equation that is a mixture of both x and y. You just be differentiating it. You will not be using any formula. You just be differentiating it and be going. Now, your function is usually made up, your equation rather, is made up of x and y. So the trick to implicit differentiation is that whenever you differentiate x, you leave it like that, you just differentiate x. But when you differentiate y, you attach dy by dx to it. Let's use an example to illustrate what I'm saying. Alright, here they ask us to differentiate this equation. X squared plus y squared equals 25. So let's start. Like I said, you differentiate x, but when differentiating y, you must attach dy by dx. So let's start. We'll start by differentiating this first function, x squared. Differentiate x squared simply to bring down the power, then subtract 1 from the power. And if you do that, you will have 2x if you differentiate x squared. Plus differentiate y squared. If you differentiate y squared, you are going to have 2y. But like I said, anytime you differentiate y, you must attach dy by dx to it. So after differentiating and getting 2y, you will write dy by dx beside it, then equal to differentiating 25. 25 is a constant, and derivative of a constant gives us 0. So now that you have this, the next step you take is that you should make your dy by dx subject of the formula. So if we do that, to do that here, first of all, you need to take this 2x to this side first and foremost. So you have 2y dy by dx equals negative 2x if we move this 2x to the other side. So now we need dy by dx on its own. So meaning that you are going to be dividing both sides by 2y. And if we do that, we'll therefore have that our dy by dx equals, here our 2 can cancel 2, leaving us with just minus x all over y. Meaning that your implicit differentiation is simply differentiate x on its own, differentiate y on its own, but whenever you differentiate y, you must attach dy by dx beside it, and when you are done, you make your dy by dx subject of the formula. All right, let's take one last example on implicit differentiation. So let's start by differentiating your 2x squared y. Now this is actually going to involve product rule. You have the product of the function x squared and y, but the way we do it in implicit differentiation is that you don't just apply product rule. What you do is that you differentiate x, leaving y constant, then we differentiate y, leaving x constant, which is actually the entire concept of product rule. So let's do what I'm trying to say. We have 2x squared y. We have three functions here. Or rather, let's take 2x squared as one function. That's the function of x, then y as well, the function of y. So like I said, you differentiate x, leave y constant, then differentiate y, leave x constant. Now, this function, let's differentiate x. If we do that, differentiating 2x squared, if you bring down the power 2, this will give us 4x. That's differentiating 2x squared. Remember, you leave y constant. Then plus, now for the same 2x squared y, you're going to differentiate y. Differentiating y is actually 1. Yes, differentiating y is 1. So that means you'll be leaving this 2x squared constant. So that will just be 2x squared. But remember, I said whenever you differentiate y, you attach dy by dx to it. So in implicit differentiation, when you see the product of x and y, first of all, differentiate x, leave y constant, then differentiate y, leave x constant. So we are done with the product parts. Now, move over to the other parts. Plus, we have y squared here. Differentiation of y squared will give us 2y. But remember, it's differentiation of y, so you attach dy by dx. This is equal to 7. 7, derivative of a constant will give us 0. So now that you've differentiated, you have to make dy by dx subject of the formula. First of all, I'm going to move our 4xy to the other side, and I'm going to bring out what is common between these two. First of all, between these two, we have that dy by dx is common to both of them. So if we bring out dy by dx, we'll be left with 2x squared plus 2y. And this will be equal to, if we bring this 4xy to the other side, it will become minus 4xy. So we are going to divide both sides by this 2x squared plus 2y. And if we do that, we have that dy by dx is equal to minus 4xy all over 2x squared plus 2y. Now 2 is actually common in this denominator, so it will have minus 4xy all over 2 into x squared plus y. Here 2 can cancel this 4, leaving us with 2. So therefore our final answer here for dy by dx is equal to, we have here, we're left with minus 2xy in the numerator all over x squared plus y in the denominator. Alright, so we've come to the end of our marathon of differentiation, not calculus. We still have integration to go into, but we've come to the end of differentiation. Do like my videos, comments, any issue you have at all, just comment and I'll attend to it. So I'll see you in our marathon on integration. Bye guys, stay tuned for more Sage videos.